Welcome back. In this video, we are going to talk about another one of the approach of divide and conquer strategy, and name of that approach is quicksort. Quicksort is a sorting algorithm. It is much faster than selection sort and is frequently used. Okay, let's understand this quicksort algorithm with the help of an example. For that, what we are going to do, we are going to take a random value of number. Let's say we are going to sort this number by using quicksort. Okay, for that, what we are going to do, we are going to take one value as pivot. Let's say I will take 2 as a pivot. One value is L and another value is R. L and another value I will take it as R. L will increment right side and it will stop when L is greater than pivot. Okay, and R will increment left side and it will stop when R less than pivot. Reason behind this concept is so that all the smaller element will come before pivot and all the greater elements will come after pivot. Maybe you are getting confused right now, but once when we will start solving this problem, you will understand what I mean. Now, when L and R get stopped, then check either the L and R is interchanged or not. If they did not interchange, then swap the values of L and R. If they interchanged or at the same position, in that case, swap the value of R with pivot element. Okay. Here, one more thing, R is less than or equal to pivot. Now, let's start solving this problem. Now check, 4 is greater than 2 or not? Yes, 4 is greater than 2, then L will stop here. Now let's check it R. R is less than 2? Yes, R is less than 2. Now check again, the values of L and R are swapped or not? I can see that the values of L and R are not swapped. Now check that the values of L and R are interchanged or not? I can see that here the values of L and R are not interchanged. In that case, swap the value of L and R. Now it is going to show it like this: 2, 1, 6, 8, 9, 7, 5, 3, 4. This is our pivot. This is L and this is R. Okay, now check again. 1 is greater than pivot? No. Then we will move into the next value. Next value is 6. 6 is greater than pivot? Yeah, 6 is greater than 2. Then it will stop it here. Now check here. 4. 4 is less than 2? You can know. 4 is not less than 2. That is pivot value. Now check the second value. It will move into R is moved to next to the value. What is next value? 3. 3 is less than 2? Less than or equal to 2? No. 3 is not less than equal to 2. Move into next. 5 is less than or equal to 2? No. 7 is less than equal to 2? No. Move into 9. 9 is less than equal to 2? No. 8. 8 is less than equal to 2? No. 6 is less than equal to 2? No. Now 1. 1 is less than equal to 2? Yes. Then this one it will be R. So this thing is L and this is R. Okay. Now what is the first question? First question is check the value of L and R. Are they interchanged? Yes, I can see that this time the value of R and L is interchanged. If that is interchanged, then swap the value of R with pivot. That will be swap the value of 1 and 2. So new value will look like this. Okay. Now pivot has reached its position. Okay. And before pivot the values are smaller in size, and after pivot the values are greater in size. So pivot value is fixed. Now here you can see that before pivot only one value is there, so no need to sort now. After pivot there is values are there, they need to be sorted. So 1 and 2 find their position. Now we have to sort this value. 6, 8, 9, 7, 5, 3, 4. So we will repeat exactly the same way we did. One value will be represented as pivot. So for this time I will take 6 as the pivot. 8 I will take it as L and 4 I will take it as R. Now check. 8 is greater than 6? Yes. Then it will stop it here. Now check it in the R section. 4 is less than or equal to 6? Yes, that is also true. So the values are interchanged, L and R? No, they are not interchanged. In that case, swap the value of L and R. So the new values which will look like this. 6, 4, 9, 7, 5, 3, 8. Okay. So this is the P, L, R. So 4 is greater than 6? No. Then L will move to 9. 9 is greater than 6? Yes. Then it will stop it. Now 8. 8 is less than or equal to 6? Look in no. 3 is less than or equal to 6? Yes. So check the value again. Are they interchanged? The values of L and R? No. If not, then swap the values of L and R. The new value will look like this. 6, 4, 3, 7, 5, 9, 8. Okay. Now check the value of L and R. 3 is greater than pivot? No. Then move to 7. 7 is greater than pivot? Yes. Then fix it 7. Now 9. 9 is less than pivot? No. 5. 5 is less than pivot? Less than or equal to pivot? Yes. Now new values of L. These are the new values of L and R. Are they interchanged? No. If not, then swap the values. Now 5 is greater than 6? No. Move into 7. 7 is greater than 6? Yes. Then stop it here now. Here. Now it will take into R. R is less than or equal to 6? No. Then move it into 5. 5 is less than or equal to 6? Yes. Then the value of R and L. So values are interchanged. If the values are interchanged, then what is the condition? Then replace the value of R with pivot. So it will look like this. 5, 4, 6, 5, 4, 3, 6, 7, 9, 8. Now here we can see that pivot value reached its position. Correct? Now there are two values it became. Two parts it became. 5, 4, 3 and 7, 9, 8. So just like 1 find its position, 2 find its position, 6 find its position. Now we have to sort the values of between 5, 4, 3 and 7, 9, 8. Let's see how we will do that. Okay. Now 5, 4, 3, 7, 9, 8. One value as P, one value as L, one value as R. One value is 5, 4, 3 and another value is 7, 9, 8. First of all, I am going to resolve 5, 4, 3, then I will look into 7, 9, 8. Okay. Now 5, 4, 3. So 4 is greater than 5? No. Then L will move into this section 3. So 3 is greater than 5? Okay, no. Okay, then it will go into further, it will stop, there is no value outside. Next, 3. 3 is less than equal to 5? Yes, that is true. So the value of L and R are interchanged? Yes. L crossed, it reached at the end position and R is here only. 3 is less than or equal to 5. In that case, swap the value of pivot with R. So pivot is right now 5 and R is 3. So swap the values, then it will look like this. 3, 4 and 5. Alright. So this is pivot also found this fixed position. Now 3 and 4, two values are there. So we have to swap these two values. So one value I will take it as 3 and 4. One value I will take it as P and 4 I will consider both L and R. So we know the rules. So first of all we will check. 4 for the 4 in L part I will take it as 4 is greater than 3. If yes, then it will stop. Now for the R part, 4 is less than 3, 4 is less than or equal to 3, if no, 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 then it will move into this section, R part. In the R part, what it will? 3 is less than equal to 3, click yes. So this one will become R. So according to the value, replace R with pivot. So this is the pivot and R is both are same. So this is fixed. 4 also, it will restate out here and there is no other values to divide. So this is also fixed, and the 5 also we have done the pivot. 5 also found its position. So that is also fixed. Now let's see here 7, 9, 8. Now 7 is the pivot element. Now 9 is L and 8 is R. So 9 is greater than 7. Yes. Then it will stop. 8 is less than 7. No. 8 is not less than or equal to 7. Then it will move into 9. So 9 is less than or equal to 7. No. Now it is 7. 7 is less than or equal to 7. Yes. So R and pivot both are same. Yes. R and pivot both are same. Then swap the values of R and pivot. So 7 will be reached its fixed position. Now here will remain only 9 and 8. Now sort the values of 9 and 8. So one value I will take it as P, another value I will take it 8, we will take it as L and R both. So P is 9. So first value we will take it as L. 8 is greater than or equal to 9? No. Then it will 8 is greater than 9? No. Then it will move into further. Okay. Now R part. R 8 is less than or equal to 9? Yes. 8 is less than or equal to 9. In that case, swap the value of R with pivot. So it will look like this. 8 and 9. So 9 also found its position. 8 also found its position. And here 6 and 7 also found its position. And here 1 and 2 also found its position. So if I will see that all the values found its position. Correct? So if I will write it like this, it will show so I can see that all the values are sorted with the help of a quicksort algorithm. Now the time complexity of this algorithm is n log n. Which will accept in both the scenarios, best case and average case. Okay. Now what we will do next, we will take one more example so that we will understand quicksort algorithm in much more deeper way. And this time what we will do, we will take out already a sorted value. Let's say okay, but already we have taken a sorted value, but our quicksort algorithm doesn't know this value is sorted. Then how it will differentiate the value? Means how it is going to sort the value according to the help of quicksort algorithm, and what will be the time complexity? Let's see. So first value I will take it as a pivot. So first value I will take it as a pivot. Another value I will take it as L, and another value I will take it as R. Now check. 2 is greater than 1. Yes, then it will stop it here. 9 is less than equal to 1, no, then it will move into 8. 8 is less than equal to 1, no. 7 is less than equal to 1, no. 6 is less than equal to 1, no. 5 is less than equal to 1, no. 4 is less than equal to 1, no. 3 is less than equal to 1, no. 2 is less than equal to 1, no. 1 is less than equal to 1, yes. Then this one will be our R. So, first of all, what is the process? According to the law, we have to check either L and R is got interchanged or not. In this scenario, yes. If it is interchanged, then swap the value of R with pivot. So in this case, R and pivot are both the same. So 1 got its fixed position, and the remaining values that we have to solve is 2, 3, 4, 5, 6, 7, 8, 9. Now let's sort the remaining values. So this one I will take it as a pivot, another one I will take it as L, another one I will take it as R. Okay, now same thing I am going to repeat again. 3 is greater than 2. Yes, 3 is greater than 2, then it will stop. Same thing with the 9. 9 is less than or equal to 2, no. Then it will move into slowly or slow. 8, 7, 6, 5, 4, 3, 2. So here I can see that the 2 is only less than or equal to 2, and the values got interchanged. So again, we have to replace swap with r with pivot, and this will be our r. So do that please. So pivot will found its fixed position, and the remaining values that we have to sort is 3, 4, 5, 6, 7, 8, 9, and this is going to run for a long time. Same thing I am going to repeat again. So again we found the 3 fixed value, and the remaining values that we have to sort 4, 5, 6, 7, 8, 9. This is the P, L and R. What is the law? L should be greater than pivot, then only we can stop, and R should be less than equal to pivot, then only we can stop. So if we'll again implement the value according to that, then we will find it out R and pivot are same, then we have to swap the value again, then it will design it like that. And like that it will goes on, and in the end we will last value it will be 8 sorted to 9, and in the end we will figure it out that all the values of 1, 2, 3, 4, 5, 6, 7, 8 and 9 are sorted. This sorting is a worst case scenario of a quicksort, and the time complexity of worst case scenario of quicksort is order of n square. Okay, but this worst case scenario is also can be minimized by choosing the right pivot element. If you have seen the example, then you will know that most of the times I have taken pivot as the first value, correct? But what if I will choose pivot as the middle value? Then the time complexity from n square, it will become order of n log n. Through that, by choosing the right pivot element, we can minimize the time complexity of quicksort. So what are the things that we covered here? We saw the quicksort algorithm, best case, average case with the help of their time complexity and with their time complexity. We have also covered worst case scenario of quicksort with the help of examples that can also be minimized by using right pivot element. Now what we will do next, we are going to see the code of quicksort in Java. Okay, through that we will understand how quicksort we can write in an algorithm way. So for that we are going to use Java programming language. It is the same thing whatever we have explained it here, but we are doing it in a code part. Okay, let's So you can see that the quicksort algorithm of this Java code works. It is the same thing exactly, whatever the thing that I have explained it to you in the design, with 1 or 2 minute difference. For example, in the pivot you can see that in the example I have taken always in the beginning, and here I have taken as an end. Okay, this is 1 or 2 differences that I have taken. Other than that, everything is exactly same. And already we have told you that divide and conquer is a completely recursive approach. So here also we are using recursion only, so that our sorting will do faster, and the time complexity of this program is n log n. Okay, with that, this is the end of the video, and the practice code I'm going to post it into the GitHub, and GitHub link I will give in the description section. And in the next video, again, we are going to talk about another one of the approach of divide and conquer strategy. So stay tuned and keep watching Adhyan channel. Thank you.